Okay, hi students. I want to demonstrate a concept called strike and dip before I actually show slides on the strike and dip. I wanted to demonstrate it with some visuals here. And so I'm gonna not run through everything about strike and dip, but I'm going to do hopefully enough that these slides will make sense. The reason we need something called strike and dip is a way for us to measure the orientation of rock units. And we're usually talking about sedimentary rock units when we do that. So when we're talking about strike and dip, we're talking about what the orientation, I just repeated myself, so just you can forget about that last part there. The orientation of a lot of sedimentary rock units is horizontal, which means they haven't been disturbed. They start out as horizontal and they've been uplifted fairly gently and they remain horizontal. This is true for the Ozarks, it's true for the Colorado Plateau. And in these situations, the structural geology of them is really straightforward. To describe these, all you say is they're horizontal, they're flat lying. And you don't even need something like strike and dip. The structure of these is really simple. But we don't have to go very far from Northwest Arkansas. We go south to the Ouachitas and we find tilted rock units. They have been tilted by tectonic forces. So rather than three horizontal layers here, or even multiple layers, because I've got a lot of pages in there, rather than three horizontal layers, maybe we have three tilted layers. And they could be tilted this orientation, or they could be steeply tilted, or they could be tilted in this dimension, this direction. So the range of orientations of the rocks is really quite, it's variable. It's practically infinite. Well, strike and dip is a way for us to measure those orientations. And the symbol for strike and dip, it looks like what I have here on the whiteboard, but also looks like here. It's a long T. And the long part of this is the strike. Well, the strike is simply the direction the bed is trending. And for me, it works best if I think of strike, or if I think of our tilted sedimentary rock unit as being like half of a roof. So roofs tend to be tilted at houses. House roofs tend to be tilted. If you imagine this as being half of the roof, maybe the other half could be another bed, but usually when we're seeing tilted rocks out in nature, we're just seeing the half here. Well, if you were to walk along the crest of that roof, you would be walking along the strike direction of the rock unit. So if the roof was made of a rock slab, then the crest of the roof would be the strike direction. And in order to determine what that orientation is, we just pull out a compass and we measure what direction that is pointed relative to north. What I'm going to have you do is just do general strike direction. We're just going to say, is it generally northeast or is it generally northwest? And we're not going to be measuring the angle like we would if we were doing face-to-face classes. The second part, though, is the dip. This is the strike part of the symbol. This is the dip part of the symbol. The dip is simply how steep the roof is. So a tilted sedimentary bed like this has a gentle dip. The angle that it makes with horizontal is low angle. It's like 5 or 10 degrees. This is making a 45-degree angle with horizontal, and this is making a 90-degree horizontal. So for dip, we just measure how steeply the bed is tilted. This symbol points in the dip direction, this symbol points in the strike direction, so that when we see them located on a map, we know that at that location on a map, the rocks are striking that way and they are dipping that direction. And these numbers tell the angle of dip. So this rock unit is dipping at a 23-degree angle and it's striking northwest. Why is this important? Because sometimes we get a dip reversal on a map. So in the case here, we have dips pointing towards the northeast, but over here we have dips pointing towards the southwest. Well, notice my map here. I've got dips pointing that way, and I've got a dip pointing that way. Well, how can we have that happening? Really, this pointing this way is that, this pointing that way is like that, but I've got both here. The only way that that works is if this is folded. So when you have a dip reversal on a map, when you have dips pointing in opposite directions, that indicates folded sedimentary rocks. It indicates rocks that were once horizontal, but they were buried deep in the earth. They got squished, shortened, and thickened by compression, so that now nearby each other, you have fold limbs pointing in opposite directions. And the fold can be like this also. Notice here we have the dips pointing towards each other. Well, that would indicate a trough-shaped fold. This is a trough-shaped fold. This is the map pattern for an arch-shaped fold.